to maximize expected value, we can also use decision trees. And the advantage of decision trees is that they can also solve multi-stage dynamic problems that we will encounter later. Now, in this problem, this is a single-stage problem where we have one decision to make, where to purchase land, or if at all, and then one chance event. The airport was built in location A or location B. But in more complex problems, we will have multiple stages. There will be one decision, then a chance, then another decision, then a chance, and possibly repeated stages like this. Now, obviously, if the decision tree can take multiple stages, it can also deal with a single stage. So I'm going to create a decision tree for this problem to solve the same problem of maximizing expected value. And notice we should get the same optimal solution, which is to choose location B, and the expected value should be $3.4 million, $3 million and $400,000. So if you want to build decision trees, there are several add-ins available. Some of them are free of charge, and many companies provide paid add-ins. We will use the Palisade precision tree. So basically, you need to double-click the precision tree link or start it from your start menu. I have already done this, and so I already have the add-in activated here, right? So I have this precision tree, and I'm going to actually open a new sheet within the same workbook, and I will then click decision tree in the left bottom corner, right of this toolbar, and then what it says is it asks me where to create the tree, and I'm going to click create it here in this cell. You can name the tree. I'm just going to put it Magnolia, and there are several options that we will not discuss at this moment. And so when you create a tree, it has just one node, and we have to start editing it. So first thing you need to do is you have to click on this node and change it to what you would like. The two types of nodes we will use is decision node and chance node. And if you recall, the sequence of our events is first we need to decide where to buy the land. So I can click decision, and then I have to create enough branches to represent the decision options, decision alternatives that we wanted to define. I'm going to call this decision land purchase decision, right? The first branch will be buy location A. The second branch will be buy at location B. And I'm going to add branches plus and plus. And I will say location A and B. And then I will say none here, right? Now we can also provide payoffs. Now, if you recall when I was saying when we put payoffs on branches, we put the immediate payoffs that are related to the actual decision at this point, right? So we can write, or we could actually provide references here to the table that I had earlier, but I'm just going to write the numbers. If you recall, the purchasing the land at location A was costing us $18 million. So I have to put a value here, payoff value minus 18. Location B was minus 12. Both locations, well, you pay for both. So it's 12 and 18, that's 30 million, but negative 30 to indicate the cost and 0 for none, right? If I click OK now, you'll see that tree is updated and you see the square here for decision, and then A, B, A and B and none as the 4 decision alternatives, right? This corresponds to what we had in the rows of the table. Now we have to edit the tree further because at this point we need to put a chance node. Once we decide to purchase at location A, we have to have a chance node that indicates whether the airport is actually built at location A or at location B. So I will click again on this node and change it to a chance node. And when it is a chance node, I actually have two options. Let's call this chance node first airport location. And then I will name this branch just A and this branch B, right? And notice that I'm not going to worry that the names of those options are the same as here, A and B, because I know this is the chance node where I'm deciding airport location, right? Now I need to update probabilities. If you recall, the airport at location A has probability 40%, and at location B, 60%, right? And I can also put values. Now, the interesting thing is, what are the values? Remember, this is the node at this point when we purchased location at land at location A. And if the airport is also near location A, the value is, the payoff, the immediate payoff is 31 million, right? Notice I'm not subtracting here 18. 18 was taken care of when we chose the land. When the chance happens, and it actually is, the airport is at location A, we just put the plus 31. And if the airport is at location B, then the purchased location A gives us only net present value of all future revenues is 6, right? So now if I click OK, you will see this node was changed to a chance node called airport location A and B with these probabilities. Probabilities are here, and the payoffs are here. And you will see that the actual values 13 and minus 12 that we had earlier in our payoff table, right? You recall in our payoff table, we had these values 13 and minus 12, right? And the expected value was minus 2. If I go now to my tree, right, you will see I still have this 13 and minus 12. And because I put the probabilities, the expected value here for this chance node is minus 2, is calculated here automatically, right? So I didn't have to put the sum product. The sum product is automatically put here, taking those probabilities and taking these end values. And notice these values are calculated by aggregating, by taking plus 31 and minus 18, basically tracing all payoffs back to the root node, or from the root node to this. They are all added up to give 13 and minus 12. These probabilities I'm going to discuss a little bit later. Now, notice I have to actually do exactly the same chance node in this point and in this point. Well, the last one, really, I don't have to, because the payoff here is 0 regardless, right? If I don't buy any land, I don't care where the airport is located. So this is a final, the terminal node. But in these two, I need exactly the same chance node. Well, not exactly the same, but very similar. So instead of just entering it twice again, I can right-click. Now, before I was left-clicking to edit the node. Now, what I want to do is I want to right-click on this node, and then I want to say copy subtree. So actually, this is a very useful function because you can copy very large parts of tree. But now this is a small subtree that I want to copy. So I click copy, and then I right-click here, and I can paste this subtree. So if you paste, notice this node, it will replace, it warns you that this node will be deleted with whatever information. Of course, I want to proceed. And you see now it changed. And the nice thing is that I already have the name, airport location. I have the options A and B. I have the correct probabilities. What is incorrect is these numbers. The payoffs are not 31. 31, when I chose location A and the airport is at location A, I get $31 million of positive inflows. Whereas here, if I chose location B, the payoff will not be 31. The payoff here will be only 4, because right, the location B that I bought is worth $4 million, if you recall, when the airport is actually not at location B, right? So this, and notice I can actually click on this and change it here, 4, but I can also edit here directly some of these numbers. Don't edit those that have formulas in them, but those that are probabilities or immediate payoffs, you can edit them here, and even the names, I believe you can also edit here, right? So here the payoff when I bought at location B and the airport is at location B, this is the good value. This is where we get $23 million for having the right location B, right? And again, you see the same numbers, minus 8 and plus 11 that we saw before in the table, and there is the expected value, 3.4 for this chance node. And so finally, I need to also paste here. I can still right-click and paste. Again, there is the warning. And again, I can change those payoffs. And if you recall, I need to put here the revenues that were for both airports, for both locations, for both parcels. So this 31 is for having location A, but I have also location B, which is the wrong one, and it gives me $4 million. And if you recall, if I have both locations, but the airport is at location B, the values will be 6 plus 23. So it will be 29. And again, you see the end values 5 and minus 1, and the actual expected value for this chance node is 1.4. So what we see here is actually the same data that we saw before. Let me zoom out this a little bit. Zoom this out. So you see here the same information that we had in the payoff table, just represented slightly differently. So I want you to also understand every chance node actually calculates expected value. It takes this 13, which is the value at this node, and this minus 12, value at this node, takes this probability 40 and 60% and calculates minus 2. Right? This is the expected value, probability times this value, probability times this value added together gives us a loss of $2 million. This now becomes a value for this node. Similarly, this 3.4 is the same kind of calculation done for this subtree and becomes a value for this node. This node, the same value, the same calculation gives us 1.4, and this node has value 0, not calculated, but just given directly, right? So now when we solve the tree, it's like the tree is solved automatically here for us in a backward manner. We move back one level, and we're at this node. And the question becomes, what do we choose? Now, this is not a chance node. There's no probabilities for us buying at location A or at B or A and B or none. It is our decision. So we can actually decide, and we are in control of this. This is not a chance. This is a decision. So we can choose this, and we would get a loss of $2 million on average. Remember, probabilistic average. We can choose this node, and we would gain 3.4 on average. We could choose this, and we would gain 1.4, or we could choose this, and we would gain 0, and this is actually a certain 0. Unlike these three that are probabilistic averages. So obviously, automatically the tree is already taking the decision for us. It is choosing the highest value, which is 3.4. That's why you see here true as the choice value, and here false, false, and false, right? False here and false here. This is the chosen value. And notice, by the way, again, the value is copied for us. So right, like here, the value was calculated for the chance node by taking expectation with these probabilities of these values. And here now, if the choice is made to choose location B, the value 3.4 is just copied from this. Right? Again, there is a formula that actually solves this. So the solution here, I hope you see, is the same as in the payoff table. The solution is buy land at location B, because that gives us $3.4 million of expected profit, right? It's the same solution. And the decision tree, of course, for this simple problem is unnecessary. But if we had a more complex problem with multiple stages, then the decision tree would be very useful. Also, I want to emphasize that the payoff table that we did before, we didn't need any add-in. This was pure Excel. The decision tree, however, required an add-in, in this case, the precision tree add-in from Palisade Decision Tools suite. And finally, I want to say something about the values that you see here at the end. So I hope you recognize these numbers, the not percentages, the actual simple numbers, positive or negative, are actually terminal values, terminal payoffs. These are the same values that we had in the payoff table before, right? -1, and then the 0. We had it twice in the payoff table because we had it for whether the airport is at location A or B, it will be 0, but we didn't need to add a chance node at this point. But we also see here is probability. So for example, it says here probability to be in this node is 0%, or in this node is 0, this node 0, but this one 60 and 40 and then 0, 0. Why is it 40, 60 here and then 0 everywhere else? Well, you see, in the decision tree, when we have decisions, but also we have chances, We don't know at which terminal node we will be for sure. But once that the tree is solved, we have a subset of terminal nodes in which we may end up, right? So because we take the decision to buy land at location B, we limit ourselves to this branch. We will never go here. That's why it's 0% here. We will never go here or never go here. So all of those are 0%. But if we go this way, we don't know, because this is a chance, we don't know whether the airport will be built at location A and we will get a loss, or the airport will be at location B and we will have a profit, right? All we know is there is a 40% chance of being in this node at the end, or 60% chance of being in this node. So what we can actually create here is, first of all, we can say our optimal plan is actually quite simple, right? Our optimal plan is to buy at location B, right? This is the decision. We can say that maximum expected value that we obtained is 3.4. It's this value at this first node that we see, 3.4, right? But we can also say something, we can also talk about something called the risk profile. Risk profile lists all outcomes. So what are all outcomes? And what are their payoffs? And what are their probabilities? Right? So if you think about it, the risk profile is kind of represented for us here, right? Where the outcome might be we buy B and airport is at A, right? At location A. This is this branch. We buy at location B and the airport is at location A. In this case, our payoff is, as you see here, -8. And probability for this is 40%, right? And the other option that we see here in those probabilities is that we buy at location B and the airport is at location B. So then the payoff is 11, as you see here, and the probability of this is 60%. And if you list, right, this is a kind of table. If you list all those options that might happen, right, then I want you to see that we can calculate expected value again from this. Expected value is what? Is sum product of those values, -8 and 11, with those probabilities, or probabilities and values. The order doesn't really matter, right? And we still get 3.4. So basically, if you wanted to report the solution that we obtained using this decision tree, you would say a plan, in this case, it's a simple plan, just buy airport at location B. But remember, later on, we'll have multiple stages. So you might say buy at location B, and then if something happens, take another decision. If something else happens, take another decision. So the plan can be multi-stage. We have one expected value that we obtain, but we also have all possible nodes, right? The risk profile lists what we might get at the end, right? Which gives us a more complete understanding of the situation, more than just looking at expected value, right? We said expected value is, maybe I'll list it, 3.4, right? Expected value is 3.4, but this expected value is actually a probabilistic average of possibly losing $8 million or gaining $11 million with these probabilities that you can see, here.